Assalamu alaikum warahmatullahi wabarakatuh. Dear students, inshallah I will briefly explain to you how to set up your MTS simulator using the settings given to you in your in the module on the exercise. For example, doing practical task 11.2, module 11, parallel turning, which aims at reducing the diameter of the workpiece from 30 millimeters to 15 millimeters for the length of 45 millimeters. The settings given to you is as shown here. Setup sheet information, the parameters, where the initial workpiece length is 67 millimeters, workpiece diameter is 30 millimeters, material is aluminium, okay, the aluminium alloy, aluminium and magnesium alloy. The choking depth is 14 millimeters. The workpiece zero location, the right side in the center of the workpiece surface, and we have one tool in position number 4, and it's of the category corner tool left, and it's a DCMT 070204. We have a maximum spindle speed of 2500 RPM with a constant cutting speed 150 meter per minute, and then we have a feed rate of roughing for roughing is 0.08 millimeter per revolution, and then the feed rate for finishing 0.03 millimeter for every revolution. If we start our TopCam MTS software, okay, you can see here TopCam. Okay, the start TopCam, that's for if you want to use computer aided manufacturing. Top mill is for milling, okay, CNC milling, and top turn is the one that we will use to cut this workpiece. So choose top turn, and then controller type, okay, is the one that we have in our workshop, which is the FANUC, okay, and this is the controller we'll use. Start turning, start turning. This is the simulation space or window. We will have to set up or complete our settings before we start writing the program, the NC program, which is the numerical control program. We'll go to setup dialog, as we said F7, to initiate a new or create a new file. I'll call it RSA as the initials, my initials, and then task 11.2. In your case, there should be you should write your name and then your section, and then I'll go and put it in my desktop. Open. Sometimes it will take you to my computer, doesn't matter, okay, and then you can later on save it in your on your desktop. Alright, so this is my setup turning. This is the file name that I gave to the file. Alright, my program number 1, and then the workpiece, all the information about the workpiece. It says here the length is 67, the diameter is 30, and the material here, the aluminium, magnesium alloys, okay, and then I will tick, and then it's a cylindrical shape as you see here, okay. Then I'll go to my workpiece clamping, next option. None of the information given here is none of the information required here is given to me. except for the choking depth. So for the choking depth, you see here, this is the only information given to me. Okay, choking depth. So I'll go to my choking depth, 40 millimeters. Then nothing else to change here. I'll go to my 0 register. If your clamping device type is given, you'll choose it out of these two. If your lathe choke is given, you can choose it from this window, these two. And if my choke jaws are given, you can open this window and select the one given to you in your exercise. Okay, there are different types. You can change the way your clamping device clamps the workpiece, like that. It says there's a warning here. It's not possible. You can change it this way or this way, doesn't matter. And then this usually is according to your to the size of your workpiece. Size is quite small, 30 millimeter dia. I'll next go to 0 register. In this area, we don't change anything. Why? Because this is the machine coordinates or 0 points. Okay, so we don't change it because this is set by the manufacturer. So we don't change it. This is the main reference point. And in this area is my workpiece 0 point of coordinates. This is the one I change because this is the one that I'll be working on. You can see the machine 0 point is here. This is my workpiece 0 point. The workpiece 0 point is the one that I control. So any changes in the length or the diameter, okay, 0 point location is considered here as well. So if I say here, say 10, can you see? There is a 10 millimeter difference between the machine 0 point and the x-axis of the workpiece 0 point. Workpiece 0 point is always x is always 0, so it cannot be anywhere else other than the center. Okay, if I change the Z direction of the value, you can see 10 millimeter. Okay, right side of the workpiece, right side here, you can change to center of the workpiece. You can change to left side of the workpiece, or you can make it same as the machine coordinate. That will shift it to the same position as the machine coordinates. So if I say 0 here, it will be 0, 2 here. Both are the same. So it's right side as given in my exercise here. Right side, center of the workpiece. That's my 0 point here, always here. And we can see that we have a 2 millimeter facing required. The original length was 76 and the finished part is 65, 67 and 65. 2 millimeter difference. This 2 millimeter is the amount of facing required. So I have to put it here. You can cut 2 millimeters later on, but I prefer always to write it in my settings, okay, because this will make my life much easier later on when I start my programming. Can you see? It's 2 millimeter, 0 point in the Z direction, shifted 2 millimeter into the workpiece. Okay, so I can just show you better here. Can you see 10 millimeter minus, or the negative 10 millimeters towards the choke or in the workpiece? Okay, but usually the amount of facing I always put here. I'll go next to my tool system. It's already populated. We have 8 positions in the turret. The position given to me in the exercise is position number 4. Okay, corner to left, and then DCMT 07, 02, and 04. I'll select position number 4, right click, I'll remove the existing tool, and then double click to select my own tool, which is the corner to left. Double click here, and then I'll go to find the DCMT 07, 02, and 04, which is this one. Double click on it, and then I'll just tick here. I'm done with my settings. I've selected my tool, I've selected my workpiece dimensions, and I've selected the choking depth. I've selected my 0 register, 0 point, workpiece 0 point, of course. And then I will say OK. I'm ready now to write my program. Okay, I'll go to my NC editor, okay, numerical control editor. Okay, double click on it. I need to start my M blocks. Okay, M blocks, which are the address of my NC blocks. Okay, just like I explained to you in the Excel sheet, you have all the rows numbered and all the columns are lettered. Okay, this here works like in the Excel sheet, the rows in the Excel sheet. Okay, I need to recognize my blocks by N numbers. Enter, and then it appears to you. Okay, and then first thing I need to write is I want to make sure that my program simulator recognizes my settings. Okay, so I'll write G54. Without G54, my simulator will not recognize any of the settings that I've made or the changes I've made in the settings regarding the workpiece dimensions, regarding the tool, select tool, regarding my 0 point. Okay, enter, and I will go to my see what else is given to me. You can see maximum spindle speed is 2500 RPM. Okay, so my G92, to limit the maximum speed in case I transfer this NC program into my machine, I want to limit to avoid any mistakes later on of writing or overwriting the speed. I will limit my speed, maximum speed limit, spindle speed limit to S 2500. This is only a precaution, okay, just to make sure that if I make a mistake writing my speed, it will not, my machine will not overspeed. Okay, this is just to limit the speed of the machine, 2500. And then I will see what else is given to me. Constant cutting speed was given to me 150 meter per minute. Can you see meter per minute, guys? Well done, you've guessed it. It's a G96. G96 command is the command I will use for constant speed limit if the speed is given in meter per minute. I need to write my speed, feed, and M direction, which is M3. 150 speed meter per minute. The feed, I need to check my feed. My feed here for roughing 0.08 millimeter per revolution. So 0.08, and then M3 for clockwise rotation of the spindle. Okay, my machine is rotating now with a speed of 150, a roughing feed of 0.08 millimeter per revolution, clockwise rotation of the spindle. Now I will select my tool in position number 4. I'm ready now to cut. What I need to write now, because there is a facing amount that needs to be removed, 2 millimeter facing, I will bring my tool from the tool changing position just over my diameter, over the point where I want to cut. So rapid positioning, okay, to bring the tool quickly to the position. And then since my diameter is 30, I will put it over my diameter, maybe 31, maybe 32, maybe 33, 34, whatever I want, but above 30. Okay. And then my Z is 0. Well done, because in my settings I made my Z as a 0 point in Z -2. Okay, so I will put it there right over, made a mistake here, it should be 31 or 32 or 33, above 30, and then Z over the 0 point, exactly over the 0 point, ready to cut G1, X0. That will take my tool to the X0 point, to the middle of the workpiece. So it will remove 2 millimeters, okay, and until it reaches X0, which is the middle point. I'm done with my facing. 2 blocks only for facing, very simple. Now I want to start my cycle, roughing cycle, which is G73. For G73, I need to bring my tool to a good position to start from. A good position, guys, is to the diameter, okay, level to the diameter, which is a 30 millimeter dia, okay, without touching the workpiece. So I will put it Z1, so I will put it to X30, right, you know, the same level of the diameter, and then Z1, because it will not touch. If I say X30 Z0, my tool will touch the workpiece, okay, and that might cause collision. We don't want collision here, so I want to remove my tool to a level, a good level to start from, a good diameter to start from, you know, my cycling, my roughing cycle, which is G73, at the same time without touching the rotating part, and that will be in a positive Z direction. Okay, so this is the positive Z direction, and this is the negative Z direction. I want to put it not far from the workpiece, so Z1 is okay. Okay, so G0, X30, Z1. You can say Z2, Z3, whatever, but it's good to not take it that far from the workpiece, because the feed is quite slow, 0.08 millimeter per minute, per revolution, sorry. Now I can start my roughing cycle. I'll write G73, and then I'll go to my parameters. In the parameters, I need to fill how much I want to cut every turn. Okay, I want to cut 1 millimeter every time, and then how much do you want the retraction to be? We said retraction is the amount or the distance the tool will move away from the workpiece after it finishes cutting. So I want it to, some of you will say 2, some of you say 3, it's up to you. I'll select 1 millimeter. Okay, so I want the tool to move 1 millimeter away from the workpiece right after finish cutting every time. The sequence, where do you want, where this the finishing shape or the sequence of the cycle will start from? This is how, which end block, which address it will start from. Usually we said G73 will take 2 positions, so it will take an M40 and M45. That's why my cycle will start in N50. I'm not sure whether it will finish in M55 or in 60 or in 70 or in 80. This is where it will finish, the cycle will finish, I don't know. So I write any number, okay, to say 10,000, doesn't matter, I'm going to change it in a minute. Finishing in the x-axis direction, we need to go back to the exercise, okay, and see how much is the finishing, how much finishing is required here. So 0.03 finishing millimeter per revolution is required. I'll write it here, 0.03, and then in the z direction my finishing will be 0.03 as well. Okay, I'm done because I don't need to write anything else. Cutting feed is already written here. My spindle speed is already written here, and the tool command is already written here, so I don't need to repeat that. I'm ready now. There you see my cycle starts at M50. I've written it here. When it's gonna finish, I don't know, so I need to write down. I need to look at my drawing. I'll writing from right to left. Okay, so the smallest diameter I want to achieve is 15 diameter. That's my X. For how much, what is the length of that diameter is gonna be 45. That's my Z. Okay, nothing else, no other shapes or no other cuts, so it will be G1. I'm cutting now. I want to reduce the diameter to X15. Where is the length? G1, Z minus 45, and I'm done. Okay, so there is only one diameter and there is only one length that I need to achieve. I'm done now. So what I'm going to do, I will write my roughing cycle, which is G72. But before I do that, I need to change. I now know where my cycle ends. It's in 55. I want to go back. I have to go back and change this to 55 because I know now. Done. My roughing cycle, guys, my finishing cycle, my roughing cycle is done. My finishing cycle needs only very few information. 3. It needs my finished shape start sequence, which is where your finishing will start from, which M block, and where it finishes, and then how much is the feed, cutting feed. You have to give it to the same information given here in your roughing, because finishing will follow the same sequence. Okay, so 50 and then 55, very much the same blocks, cannot be different. And then my finishing is 0.03. Okay, done. And then now M30, you've guessed it, M30 is to stop the machine. Okay, so that's M30 done. I'll come and accept and quit. Okay, this is my 3D graphic, this is my 3D part, and this is my 2D graphic. I'll look at here. This is my X axis, this is my Z axis. I can see now just this is to run the program, the NC program. This is to run it with single step every time, and this is to interactively run it, where you can change commands. And this is a test run. You can test run it. That will do it quite fast, quite quickly. I will just run and see how it goes. That's rotated. It's my tool doing my facing. Okay, done with my facing. Now it will start reducing the diameter until it reaches X15. Okay, you can increase the speed manually. Okay, and that's the finishing touch. Well done, good job. I'll look at my 3D part. Oh, can you see a little material, a small material is left here. Why? Because I've selected an X30. You see, here. I need to remove that because I said X0. That's for facing. When I was doing facing, I made my cut up to X0. I need to increase that to -1 and then see how it goes. Can you see removed everything? You need to make the surface smooth as possible in order to prepare it for drilling. Okay, operation. This has to be perfectly flat. Without having it flat, it will affect your accuracy of your drilling. Okay, I hope that was helpful. Okay, you can check it here. Check the dimensions, whether your dimensions are right. Okay, this is my dimensions. You can check and see from one point to another. It's 15. How long? Should be 45 mil. Okay.